Okay. Here's a titration problem that is pretty traditionally straightforward to work, and it's pretty common on most exams. If 25 milliliters of a 0.3 molar HCl solution is sufficient to neutralize a 30 milliliter sodium hydroxide solution, what's the molar concentration of the sodium hydroxide solution? Now, the way I approach this is first to write the reaction between HCl and NaOH is a double replacement metathesis reaction. So I'm going to come here and write HCl aqueous. Now give yourself a little room so you can jot down your data and calculations. Plus NaOH aqueous, then goes to NaCl aqueous. You'll need a lot of room over here, so everything's based on the reactants. H2O as a liquid like this. Now, jot down the data that's associated with the solutions. Here we have 25 milliliters of 0.30 molar HCl plus 30 milliliters of unknown, 30 milliliters of unknown molar sodium hydroxide. Now, in this issue right here, we do not necessarily have to convert the volumes to liters. Molarity times volume is moles, and that if it was just that was being asked, if you need the moles exact in this case, you would have to convert to liters. But since when we set up the equations of this, you'll see that both sides of the equation will be the same units. Okay, so moles of HCl will equal moles of NaOH neutralized. So according to the equation, we have 1 to 1. That means molarity of the HCl times the volume of HCl, which is the moles, is equal to molarity of the sodium hydroxide times volume of sodium hydroxide. So as we look at the data that's given, we've got 25 mils of HCl solution, 0.3 molar concentration. Molarity of the sodium hydroxide is unknown, and we have sodium hydroxide 30 milliliter solution. So we substitute these in, so I have a 0.30 molar. Volume is 25 milliliters. Is equal to the molarity is the unknown times the volume is 30 milliliters. So the molarity of the NaOH solution is equal to, solving this, we have a 0.30 molar times 25 milliliters divided by 30 milliliters. So what I was telling you, and when you're using this equivalence like this, you don't have to convert to liters because the units are going to cancel and all you're left with is molarity anyway. And this works out to be a 0.25 molar NaOH aqueous solution. A second type of problem that's common is mixing of acid-base solutions, and you know what their volume is and concentrations before mixing. Here is a case of after mixing 45 milliliters of a 0.15 molar HCl solution with 38 milliliters of 0.22 molar sodium hydroxide solution, which reagent will be in excess? And what will be the concentration of the reagent in excess? Again, this is a type of titration problem as specified in the previous type of problem, titration problem. Start with the reaction and then attach the data to the reaction, convert to moles, compare the molar amounts in the reaction, and you can see the excess. Take the moles of excess divided by the total sum mole of total sum volume of the solution after mixing, expressed in liters, and you can calculate the new molarity. And like this. So if we have HCl mixed with a NaOH solution, what you will have is 45 milliliters of 0.15 molar HCl solution mixed with 38 milliliters of 0.22 molar solution. Now, when you work one of these, you need to convert to moles, and to convert each one to moles, you have to convert this to liters, divide by 1,000. So that would give us 0.045 times 0.15, and when we multiply those together, we'll have moles of the HCl plus the 0.038 times 0.22 moles of the sodium hydroxide. So I'm trying to keep up with my data here, kind of moving. That's why I say spread it out some. So multiplying those numbers, we come up with 0.00675 mole of HCl being added to 0.00836 mole of the sodium hydroxide, like that. Since the equation HCl plus NaOH goes to NaCl plus H2O is a 1-to-1 metathesis reaction, that means moles of hydrochloric acid reacts stoichiometrically or 100% with equal moles of sodium hydroxide. So if I have 0.00675 mole of HCl, all I'm going to use is 0.00675 mole of sodium hydroxide. So, and the excess will be sodium hydroxide. So what I do is come down and 0.00675 mole NaOH, and I put out here just for emphasis used. The remaining difference in this will, of course, be the excess sodium hydroxide moles. It'll be 0.00161 mole NaOH excess. Now, again, molarity and moles are not the same thing, just to emphasize that. Once we find out the moles of sodium hydroxide used, we apply and are asked to get the concentration. Then we apply the concentration molarity is equal to moles solute divided by total volume solution expressed in liters. Now you do have to express this in liters when you apply the definition of molarity. So in this calculation, we simply have the concentration brackets NaOH, which means molar concentration. The moles of solute, which 0.00161 mole of solute divided by the mix is 45 milliliters of HCl solution and 38 milliliters of base solution. So I'm going to express this 45, 38 milliliters, and 8, 9, 11, 12, 13, 4, 5, 6, 7, 8, 83 milliliters, which converts to 0.083 liters. So that's what we want put down here, 0.083 liters solution. and that works out to be a 0.0194 molar excess of sodium hydroxide. Rounding it to a couple of sig figs, we'll go 0.020 molar excess NaOH, like that. Now, like I've said before, you can expect problems like this on every exam I give. Have a good day.